All right, we're going to be talking about 3.2, solving systems of equations by elimination. So 3.1, we did graphing and substitution. Today we're just going to focus on elimination. So to do elimination, it needs to be set up to where both equations are in standard form. All that means is that you have a number times x plus a number times y equals some number. Okay, so a, b, and c here, they're just numbers. So ax plus by equals c. You want x and y on the same side of the equal sign. And for elimination to work, either a or b should be the same number, but opposite signs. So like here, I have a positive 2y and a negative 2y. So it's the same number and opposite signs. So in this case, my b, the number with y, is the same number with opposite signs. Once you have that, if you have that, then all you have to do is add straight down to eliminate. So here, I would add these together, and that would give me 2x. X plus x would be 2x. These two would cancel. It's 2y plus negative 2y is 0. Equals 6 plus negative 2 is 4. Then I have this nice, easy equation that I can solve. Divide both sides by 2. And I get x equals 2. Once you get one variable, you have to substitute it back in to either equation, whichever one you like better, to get your y. So maybe I really like this top equation. So now I have x plus 2y equals 6, but I know that x is 2, so I have 2 plus 2y equals 6. I can subtract 2 from both sides, which gives me 2y equals 4. Divide both sides by 2, and I get y equals 2. Okay, so then my final answer here is x is 2 and y is 2, 2 comma 2. So what I found is that's where those two lines would cross if I were to solve them for y and graph them. That's your solution to your system, the ordered pair that works in both equations. So sometimes, though, it's not so nice. If A or B, are not already the same number with opposite signs, we have to make that happen. We have to make them the same number, and we make them the same number with multiplication. So let's look at another example. Looking at this one, right now I don't already have two numbers with opposite signs that are the exact same number. However, these would be harder to make than this one right here, because this one right here, all I would have to do is have a negative 2 here, and then they would be the same number. And I can do that by multiplication, because right now, if there's not a number there, we know it's a 1. If I really want it to be a negative 2, so I have negative 2 and positive 2, all I have to do is multiply this equation by negative 2 before I get started. The only thing about that is if I multiply any part of the equation, I have to multiply the entire equation. So that whole top equation, I'm going to multiply by negative 2, which gives me negative 4x minus 2y equals, and then even over here, negative 2 times 23 is going to give me negative 46. Oh, why did I undo that? Just really wanting to solve for y. All right, then I'm going to rewrite this equation. I'm not changing it at all. We didn't multiply it by anything, and we have our negative 2y and positive 2y already. So I'm just going to write down 3x plus 2y equals 37. And draw my line and add straight down. If I add here, I get negative x. Here, these cancel, which is what I want to happen. And here I get negative 9. So then to get rid of the negative, remember we just divide by negative 1. So I get x equals 9. And once I have x, I can plug it back into either equation to get y. Maybe I like the top one better, so I'm going to say smaller numbers, 2 times I know x is 9, so 2 times 9 plus y equals 23. Multiply here, 2 times 9 is 18, plus y equals 23. And then if I subtract 18 from both sides, I get y equals 5. So that gives me 9, 5 for our final answer. Remember, it's always x, y. All right. And we have one more example. This one right here, there's not one equation where I could just multiply by one number and then they'd match. There's nothing I can multiply 4 by, no whole number that I multiply 4 by to make it 3, or 3 to make it 4. No whole number I can multiply 2 by to make it 3, or 3 to make it 2. So I'm going to look for least common multiple. The least common multiple for 2 and 3 would be smaller than 4 and 3. So 2 and 3, it would be 6. So that's probably what I would choose. Though you could make these both 12. That would be okay too. So I'm going to make these both positive 6 and negative 6. So to make the top one positive 6, I'd have to multiply this by 3. To make this negative 6, I'd have to multiply by negative 2. It doesn't matter which one you make negative. So if you wanted to multiply this by negative 3 and this one by positive 2, that's fine also. So my new equations here would be 3 times 4x is 12x, just distributing. 3 times 2y is 6y, and 3 times 18 is 24. And then down here, negative 2 times 3x is negative 6x. Negative 2 times positive 3y is negative 6y. And negative 2 times 9 is negative 18. Make sure that you multiply this far side also by whatever you're multiplying the equation by. A lot of times I see people just multiply the left, multiply all the way across. Okay, so then we're going to add straight down. These cancel. That leaves me with 6x. 12 plus negative 6 is 6. Equals 24 plus negative 18 is going to leave me with 6. Divide both sides by 6 to get the x by itself. And I get x equals 1. And then I can plug it back into either equation. If I plug it into the top one, I get 4 times my x is 1 plus 2y equals 8. 4 times 1 is 4 plus 2y equals 8. Subtract the 4 from both sides. That's gone, which leaves me with 2y equals 4. Divide by 2. And we get y equals 2. So my final answer is 1, 2, x, y. And that is all there is to it. There you are. Now it's your turn. Make sure you do odds on the new stuff and all in the review on section 3.2. Let me know if you need any help.